All right, welcome to Geometry 7-1. We're studying midpoint and distance in the coordinate plane, and we're beginning to connect some more algebraic ideas with geometric ones. And the first thing is just we're looking at midpoint on a number line. And so midpoint is the middle between two values on a number line. So here we're just using A and B to represent values, but all the midpoint is for midpoint, I'll use a different color here, I'll use that orange. Midpoint is the value of A plus the value of B divided by 2. Or another way to think about what midpoint is midpoint is the average of the two values. The value of A plus the value of B divided by 2. Let's look at an example. Let's look at an example now. So in this example, it's what is the midpoint of segment AB, and I've drawn this number line here. So A has a value of -6, B has a value of 2. And let's substitute our values into our formula. So again, midpoint equals just the average of A and B. So in this case, midpoint would be -6 plus 2 divided by 2. Midpoint would be -4 divided by 2. I'll go down here. So midpoint would be -2. And let's go ahead and graph that line. So here's 0, -1, -2. And you can see that this is the middle of A and B. Again, you can count, there's 1, 2, 3, 4 spaces from there, and 1, 2, 3, 4 spaces from there. So our midpoint is -2. Knowing that midpoint is the average of two values, it's going to be the same in a coordinate plane. The thing is rather than just a linear understanding of our value, we have two dimensions, and so we're still going to find the average of these 2 points. We just got to take into account both the x and our y axis and their values. So midpoint is the average of our x's. There you are. The average of your x coordinates and the average of your y coordinates, and that's going to give you your ordered pair. That's your midpoint. So let's just write out what this is. So midpoint then is going to be x1 plus x2, and that's the average divided by 2. And then your y-coordinate is going to be y1 plus y2 divided by 2. So again, this is just like midpoint on a linear scale, except in a coordinate plane, it's the average of your x values. So in this case, 1 and 5 divided by 2 would give you your x value. And for your y value, it's the average of the y, so 1 and 3. Let's do this in an example that's more concrete. So given the same segment, let's find the midpoint. So let's just fill this in. So our x values would be 1 and 5. So 1 plus 5 divided by 2. Our y values would be 1 and 3. Plus 3 divided by 2. I'll continue this work up here. So this 1 plus 5 is 6 over 2. 1 plus 3 is 4 over 2. So in this case, our midpoint would be at 3, 2. And again, let's graph this. So 1, 2, 3, 1, 2. And you can see that the orange dot that I've placed is the midpoint, is the midpoint of A and B. So just to recap, again, the midpoint is the average of your x-coordinates and then the average of your y-coordinates. So the average of your x-coordinates was 1 and 5, which got to 6. The average of it was 3. Your y-coordinates were at 1 and 3, so which is 4, and the average of that would be 2. So your midpoint then is at 3, 2. Last but not least, we have distance formula in the coordinate plane. Distance formula is derived from the Pythagorean theorem. And just to refresh on the Pythagorean theorem says that the legs of your right triangle, so a squared and b squared, are equal to the hypotenuse squared. So just in this example here, you could see that if your legs were 3 and 4, I should say, that substituting those values, 3 and 4 would make 9 and 16 squared, equal to c squared. 9 plus 16 is 25, and the square root of each side of those, you can see that c would be 5. So c would be, this is equal to 5. Now, if I just wanted to solve all of this in terms of c, what would c equal? Well, let's do that work here. So what C would equal, if I just wanted to get C alone, I would have to square root each side. And what C equals is the square root of A squared plus B squared. Now, why am I explaining to you this? Because what we're going to learn on the next page is looking at this triangle, if it's in a coordinate plane, if this was a segment, so if this dot was here, and this dot was here, and this was segment AB, if I want to find the distance of this, okay, which we found to be 5, right, I'm going to use Pythagorean theorem. So what does C equal? C equals this squared plus this squared, and it's the square root of all of that, and that's how we find this distance. And so we're going to use the Pythagorean theorem to find distance on our coordinate plane in the next slide. So again, what does the distance equal? Distance equals the square root of your two coordinates. Well, I'm sorry, of your two coordinates. The square root of the lengths of the legs of the two coordinates that you have here. So that's going to be x2 minus x1 plus y2 minus y1. Oh, sorry, use squared. And that C would be the distance of our hypotenuse for this right triangle. So once again, let's just look at it realistically, and I'll draw another right triangle here and just call this 3 and 4, and we're solving for C. Right? So in the triangle we have here, first we got to figure out what is the distance of this leg, right? The distance of this leg is going to be my value of x2, which is 5, subtracted from my value of 1 to show that this distance is 4. So you can see that that's going to be 5 minus 1. 5 minus the 1 will give me a distance of 4. And I'll have to catch up with the y, but just to show you this. With my y's, it's y2 minus y1. So to find my vertical distance here, it would be my top distance of 3 minus my bottom distance of 1. And that gives me a distance of 2. And you can even just see visually here. I'll change my color real quick. You know, this distance is 1, 2, 3, 4. That's the distance. And I found that out by subtracting 5 minus 1. This leg's distance is, you could kind of look to these coordinates over here, 1, 2, 3, right? Which I got from, oh, I missed this 1, 2, 3, 4. This coordinate should say 4. I'm so sorry. Forgive my math. This should say 4, and this distance is 3. Yeah, but it's 4 minus 1. So this distance is 1, 2, 3, and that's how we got this. So then, my hypotenuse of this right triangle that I've made, right, is this leg squared plus this leg squared and taking the square root of all of it. So AB equals 16 plus 9, which is 25. I'm going to continue this work here. So AB equals the square root of 25. Segment AB equals 5. And we have found the distance from A to B. All right, that's it. Good luck in your book work. Refer to the book if you have questions, and talk to you next time. Bye.